Now I'm delighted to be able to open our first main session, which will focus on engineering for net zero. With the crucial COP26 conference closing just a couple of weeks ago, this is of course very high on all of our agendas. So it's very timely that our first keynote speaker, Professor Paul Monks, will be telling us more about how the UK plans to deliver its own commitments on net zero and the importance of the engineering community in meeting these goals. Paul is Chief Scientific Advisor to the UK's Department for Business, Energy and Industrial Strategy, so the same department that I work for. And prior to this, he was the Pro Vice Chancellor at the University of Leicester, where he remains a Professor of Atmospheric Chemistry and Earth Observation Science. Over to you, Paul.
Thank you, Yasmin, for that kind introduction, and thank you for inviting me to come along today to discuss this. So if I could have my slides, I'm going to help hopefully frame this session for you. It's called, these slides, Engineering Net Zero, Engineering and Net Zero. I mean, actually, it's an interesting title. Is it engineering and net zero, or are we engineering net zero? For me, actually, as we go through this talk, I think we'll find there is a critical difference for that, and we actually, and the engineering profession and science behind that needs to step up to engineer net zero. It's a critical part of this. Next slide, please. So what is net zero? Just before we kind of get into the lingo, it has a particular meaning. It also has a very different meaning in different countries, and I recognise that there's a range of countries on here. In the UK, we commit to being net zero with respect to greenhouse gas emissions by 2050 compared to 1990 levels. So that's 100% reduction by 1990. And we use a set of different mechanisms to do that, which are actually set in UK law in the Climate Change Act. But that also is the same mechanism that we use internationally to publish our nationally determined contributions, which is what was to announce recently at the COP26 conference, where all the countries of the world come forward and commit to reducing their greenhouse gas emissions. So for us, it's a seamless process that embraces that. Next slide, please. So how do we achieve net zero? What are the ways? And there's a figure on the right there looks at the abatement pathways in terms of reduction in equivalents of carbon dioxide, and the different colours there are the different ways that we're thinking in the UK that we are doing that. And this begins to talk to the heart of engineering net zero, because actually, we need to reduce demand. Yeah, we kind of forget about this, and we're going to talk a lot in a minute. I'm going to start talking about how you decarbonize the energy system and the like. But actually, if we can reduce demand or improve efficiency, then we don't need to create the energy in the first place. And that's going to be a really important element for going forward. And it's a real challenge to the engineering world can we reduce those energy demands? Can we improve the efficiency of the way that we use energy, but also the way that we use products and services as well, making them more recyclable and the like. So it's efficiency in all the ways that we use energy, either literally or embedded energy in products and services as well as then the drive towards low carbon solutions, electrification, hydrogen, carbon capture and storage, as well as generation of greater amounts of low carbon energy. And remember that a number of our emissions come from land use, and we're going to be able to have to look at land use and greenhouse gas recovery elements, maybe negative emissions as well, as part of that future of net zero. But there are different pathways, and different countries will have different pathways, and it's important that it's always understood in that context. Next slide, please. It's a systems problem, and I think it's worth remembering. And whenever I say it's a systems problem, engineers always step forward and say, actually, we are the systems thinkers. And I think there is absolute degree of truth about that. But it is a systems problem. And here again, I've just done the energy transition, going from the main energy sources to their main usage sectors on the right-hand side there, and a number of the system linkages there. But you'll notice the systems of systems problem, because that sits in a global energy transition as well as a country-based energy transition. But it also sits in other systems. It sits in the economic and financial systems, which will drive this, either in the country level financial systems and funding, or also the global economy and the global economic system, which was all very much the fore in COP26 and the second key goal of COP26. So we've got the energy transition, we've got the financial system, but also we've got consumer behaviour and behaviour change as part of that, people in that system as well. So it's a really genuine systems of systems problem, net zero. And often the challenge of talking about policy in this is actually this interconnection and these systems. And engineers are in a peculiarly good place actually to be able to talk to policymakers because of your understanding about systems and systems thinking and the ability to do that. Next slide, please. So it's worth recognising when we talk about net zero that actually it's going to require an economy-wide transformation. And here I've listed the major emission sectors in the UK economy, but actually they would be true of virtually any wider economy, looking at transport, business, power, land use, buildings, as well as some of the negative emission technologies that we're going to use. So when we talk about net zero and the net zero transition, it's going to require an economy-wide transformation. There is not any part of the economy that will not be touched by the transition to net zero. Next slide, please. But it's also remembering, and it's very easy as engineers and scientists like ourselves to become too technocratic about this, and to think that actually, it can all be achieved with technology, and it's not. It's going to be, people use technology, and also it's the way that people use that technology that is going to be critical to decarbonising the economies of Europe and the world. And we've got to think a little bit about how those link together, in particular around things like healthy diets, aviation, and also, as I said earlier, engineering products that last longer, use less resources and the like. So actually it's important to think about all the different elements of the net zero transition and not just think about it as a mitigation problem. It's a mitigation and adaptation problem, but also it's not just a mitigation problem that's driven by technology, it's a mitigation problem that's also driven by people, and behavioural change being a key element of that. And that has to be engineered into that low carbon future that we're designing. Next slide, please. So how do we achieve net zero? And if you go to a government context, and how do engineers and scientists influence that? In the UK, what we've done is we've got a series of strategies that we've put together just before COP26. And if you're interested, it's really worth a read, all 176 pages of it, about our net zero strategy, which is called, similarly to this, Build Back Greener, in some senses. And also we have a 10-point plan for a green industrial revolution that really shows the major goals in terms of decarbonising the energy system and the transport systems that are going forward. But it's these strategies and the way that science and engineering underpin these strategies which are a key element of our vision for that, and our way of achieving that. It sets out the ambition and begins to think about the way that you can deliver that on the sort of timescales. And 2030 is a key decade for that. We need action now. If you look at any of that, we've only got a small amount of the carbon budget left. So it's not also with technology and systems thinking, it's not about pushing it into the future, it's thinking about solutions that roll from now out to the future as well. Next slide, please. Just to kind of give you some framing of the scale of this challenge, this is a slide of UK energy demand over the last few years from colleagues at the University of Birmingham. At the bottom, you've got the electrical demand. In the middle there, you've got the amount of energy that's used in fuels. And on the top of that is the UK use of gas. And you can see that we're nearly using 4,000 gigawatt hours in there. And if you think about it, the future is no gas. Much of that liquid fuel will be electric. You can see that we're going to really have to be able to double our low carbon electricity generation by 2050. And you can see, therefore, the absolute scale of the engineering and science challenge ahead of us. When we're getting nearly to 5,000 gigawatt hours of electricity, it's going to be a real challenge. And I always think this is a very salient slide to look at, to kind of remind yourself of where we have to get to. We're not messing around on the edges here. We are economy-wide transformation. We are going to have to make really big changes. Next slide, please. And if you look at that journey to net zero, and I've taken these figures from our strategy on the left here, is the 2019 energy sources and end uses of those and those sectors that I've talked about, and the way that you can see the dominance of the fossil fuels in that. On the right-hand side there, you can see in the high electrification scenario, still the same usage sectors, but now the way that we're a pathway to achieving that high amount of renewables, bioenergy sources becoming more dominant, and if we're still using fossil fuel sources, those being abated with CCS or negative emission technologies as well. So that's a future that is quite strong, and it's also a future that presents a range of engineering challenges, not only in the scale of energy production, but in energy storage, in energy distribution in a system that has high intermittency. So there's a whole number of engineering and science challenges that underpin what are these broad brush approaches to net zero. And we need that, and policymakers are going to need that understanding to be able to deliver these sort of outcomes. Next slide, please. So how do we do that? How do we do research and innovation to do that? As part of the UK's net zero strategy, we produced a research and innovation framework. It makes, not surprisingly, the push that we've got to have to do a whole systems approach to this. The transformation is going to be quite large, and we need that integrated systems approach. But again, you can see the wheel on the right-hand side. You can see many of the technologies that I've already talked about. You can see the socio-economic insights that are going to drive those technology suites, and that you've got the different sectors there. Again, you've got the different technologies that contribute to that. But also, you'll see there's the enablers. Data interoperability, the digital revolution is, digital net zero is going to be important. And that's not just about decarbonising mainframes. It's about the way that we use the data to be more intelligent about how we use energy and resources. Finance, in order to deliver that. Policy, the levers to change that research and innovation thing. The skills of people and skilled people. We're going to have to change the way and the skills of the people that we've got in order to be able to deliver that, as well as an understanding of the end users and the people that will use these technologies. The point is, again, that people use technologies. It is an important part of that, and you can't take people out of that system. But that's a really good framework that brings together the sort of challenges, but also the enablers for that decarbonisation, and the central role that research and innovation in both science and engineering will make in order to deliver that. Next slide, please. If we think about science and net zero, there is no greater challenge for me. We've got to make net zero sustainable, we've got to make it resilient, and I think we've got to make it measurable. Engineering will help us with sustainability. We've got to make it resilient to its mitigation and adaptation, not one or the other. And we've got to make it measurable and real to people. Next slide, please. So COP26 in the international context of this. Next slide, please. COP26 has a wide range of outcomes. I think I would note that science has never been more to the fore than in the recent COP26. We had a Science and Innovation Day. We had science at the top of the agenda with respect to the documents that were produced. Science was threaded through everything that COP26 does, and that bringing the international countries together. So international collaboration, like we're talking about today in this Eurocase conference, is really important, and you can see some of the major impacts that came out of COP26. Was it enough? No, we always have to keep pressure on. Every fraction of a degree counts. We've got to keep moving forward on this agenda, and science and engineering will enable us to do that. Next slide, please. International collaboration is absolutely essential for that. I think COP26, if it leaves you with anything else, this is a global problem. We're all in it, and we will not be through it until we're all through it in some senses. Both the EU and the UK work together to put some plans together in terms of the COP26 Glasgow Climate Pact and the EU's Fit for 55 package, which was a very strong set of measures around that. And both the G7 and the G20, which are going to have things like the Clean Energy Ministerial and international partnerships for hydrogen and fuel cell economies, are going to be part of that as we move forward. Next slide, please. Engineering is going to be essential to delivering that. Next slide, please. And I took from the Royal Academy of Engineering's recent report of rapid, low regrets decision making for net zero policy. To deliver net zero, we need to start thinking like engineers. To make it a success, we need to stop modelling and start building. So I'm not an engineer, I'm a chemist by training, but I leave that challenge maybe to the panel to kind of pick up as part of this. But you'll notice it's that concurrent coordinated transformation, it's that systems thinking, it's putting the technologies that we have today, deploying those at scale, as well as the technologies for tomorrow. And the engineering community is in some senses, an absolutely ideal place to be able to think about how to deliver that range of visions that is going to be essential to decarbonising our global economies. Next step, please. Next slide, please. So some take homes from this. It's a significant challenge. It's pervasive, net zero. Systems approach is going to be an incredibly important part of that. And behaviour change is as well. And really, engineering, science, innovation is absolutely critical to those net zeros, and we need to do that in a framework of resilience and sustainability for the future. Next slide, please. And if you want to follow me on Twitter, that's an unashamed plug at the end of my talk, please follow me on Twitter. I tweet a lot about the issues around that and the science policy issues and science and engineering policies around delivering that. We can go back up a slide, please. So hopefully you've enjoyed my short talk and my short introduction. Hopefully I've framed to you the challenge of net zero and the role that engineering and systems thinking can play in delivering that. Thank you very much indeed.